Hi, my Math 130s. I have our instructions here. So in the past two recordings that I've posted, I went over homework alternate chapter 7 assignment, numbers 1 through 10. Please review those videos. If you have any questions, ask me. Remember, you can either join our regularly scheduled Zooms or you can schedule an individual Zoom with me. Especially if you have personal questions, the thing to do would be to schedule an individual Zoom. So during this time, I already went ahead and started the recording. If any questions pop up, please put them in the chat or you can chime in. Aside from that, I'm going to go ahead and get started. I'll take a break after this first one in case people are still joining. So let me clear this out. I'm actually going to start with number 11. So we have a graph of a quadratic function. The vertex is -3, 4. You start at the origin, you move over by 3 and then up by 4. You get to our vertex. So we have this function shown below. We want to find the domain and range. So this goes back to some of the domain range stuff that we've talked about in the past. As a matter of fact, I want to zoom in on this, if at all possible. Okay, so the first thing to note is that our vertex is right here. Okay. For the domain, let's go ahead and do that in pink. And then the range, let's do that in green. So remember, the domain covers all the x values that are defined for your function. What I want you to notice for this particular question, you have an arrow up top right here, and you have an arrow up top right here. So this arrow is pretty much suggesting that if you continue to plot points, -infinity would be the lowest value that you can technically quote unquote reach. But remember, we can't touch -infinity, so we'll put a parenthesis on it. Similarly, the arrow moving in the other direction is symbolizing that if we kept plotting points, the max would be infinity. We can't technically touch infinity though, so we're going to put a parenthesis on that too. So our domain, -infinity to infinity. Now the range, remember you're looking for your lowest point on the graph and then trying to figure out what's the y value there. So we don't see arrows going downward. We just see this lowest point right here. And there's a point here, so we are going to include whatever y value belongs to this point. So that y value, remember the point is -3, 4. The y value here is 4. So the lowest value we're going to use is 4 included. And then the arrows continuing up tell us that if we keep plotting points, we could move closer and closer to infinity, but we'll never touch it. Okay. So that covers the first problem already. There's your domain and range for question 11. A little hint for you for a quadratic function, which will be of the form y equals ax squared plus bx plus c if you had a formula for it. And this can sometimes be written in function form. The domain for any quadratic will be -infinity to infinity, okay? But the range you'll need to check, okay? All right, so far I haven't had any new visitors aside from my embedded tutor. So I will continue on down this line. Let me clear this out and move to number 12 next. Below is the graph of y equals x squared. Translate it to make the graph of x minus 5, the quantity squared. So for this, we'll have to get into some detail. And as a matter of fact, let me stop share and then let me share my whiteboard with you. Let's do translations on a separate page here. So this will be for chapter 7, quadratics. Specifically for this part, translations. And this actually works for any general function, f of x. So to start, our parent function will be y equals f of x. And for quadratics, that'll have the form ax squared plus bx plus c in standard form. Or you could have your function be equal to a times x minus h, the quantity squared, plus k, which we discussed in the last video. That's what's called vertex form. So the one that we're going to tackle here is this form. Okay, so our parent in this case would be y equals x squared, or f of x equals x squared. So a few things. Vertical translations. Okay, so if my parent is y equals x squared, and then my translated function, and actually let me use function form just so I can keep saying function, all right? Remember, your f of x value is actually equal to y. Okay. So my translated function g of x, let's cover a few things. If I have x squared plus c, you can think the parent function was right here. Okay, so the parent function you can see right here. And then whatever this y value comes out to for your original function f of x, you're adding a c value to it. Okay, so let's put the plus c in a different color too. So if c is positive, you move parent graph up by c units. And if c is less than 0, you move your parent graph down by c units. So quick example off to the side. If I have y equals x squared as my parent, keep function form. F of x equals x squared is my parent, and we will compare g of x equals x squared plus 2, and h of x equals x squared minus 2. For this part, if it's a translation involving adding or subtracting something to your parent, you're essentially changing your y value here. You're not changing your x value at all. Then what you're going to be doing, first find some x values that you want to test. And then you're going to plug them in. So -2, the quantity squared, be careful, you put -2 in parentheses, it comes out to 4. Let's do this parent in blue. So we'll get 4, 1, 0, 1, and 4 respectively. Now for your translated functions, for g of x, remember, if I plug in -2 for x, I'd get 4 from this portion. So I would still get 4 from this portion, but now I'm adding 2 to that. So it's going to be 4 plus 2, which comes out to 6. You'll do this similar thing for your other y values here. So we're going to add 2, add 2, add 2, add 2. And for h of x here, now we're subtracting 2. Note we still have our parent y value when we plug in, and now we're subtracting 2 from it. So if I were to plug in -2 for x, I would get 4, but now I'm subtracting 2. So this would give me 2. And 1 minus 2 would give me -1, 0 minus 2, -2, -1, and 2. Okay, let me save this picture. And then essentially the points are what you're going to need to worry about. So if you're graphing, you'd be graphing x, y, x, y, x, y, x, y, x, y. For g of x, graph x, y, x, y, x, y, x, y, x, y. And for h of x, x, y, x, y, x, y, x, y, and x, y. Okay. I'll leave off stretches and shrinks, which would be if you had a coefficient in front here for now. If you do run into this kind of situation in your homework or your quiz problems or anything, just let me know so I can go over it in some extra detail. All right, so I've already saved that, I believe, one more time just in case. And then let me go ahead and clear this out. We're going to go over horizontal translations now. Give me a second here. Takes so long sometimes. Okay, so horizontal translations, our parent function is still going to be f of x equals x squared. Now though, let's put this in pink, whatever. The horizontal translation, so we're going to be comparing to, one is g of x equals the quantity x minus c. Sorry, we can leave that. Let's make it a plus. Okay, so this is a little bit different. If you're thinking about vertical translations, it's very straightforward. Like if you see a plus, you would move up. If you see a minus, you move down. But in this case, let me not put that. Let me go over the basics first. So if c is greater than 0, you move to the left by C units. And if C is less than 0, you're going to move right by C units. Okay, let me save this picture. This part gets a little abstract, so let's put our little example over here. That's our parent. We're gonna have x, let's do -1 squared, and h of x will equal x plus 1 squared. So the thing here is that you're actually changing the input first before you find your y values. So it's a little bit abstract. I know I keep saying that, but it's because it's about to get weird. So first, I'm just going to graph make a table for the parent. -2, -1, 0, 1, and 2. If I plug in, okay, then -2 minus 1 is -3, square that is 9. Oops, sorry, I'm thinking about my g of x too early. Start with f of x, we're on the parent. So -2 squared, that'll be 4, and then -1, oh goodness, why am I doing this? 4, 1, 0, 1, 4. Okay, now essentially what I'm gonna wanna do for this next bit, for g of x, I wanna figure out when will I get the same y values? Okay, so for this part, 4, when is that equal to x minus 1, the quantity squared? This is for g of x. Remember, you need to take the square root of both sides, so that'd be plus or minus 2 equals x minus 1. And then we would need to add 1 to both sides, so 1 plus or minus 2 equals x, which gives us 2 results. X equals 3, and x equals -1. Okay, so essentially, we're going to split this up here. The x values that we would need to get 4 would be -1 and 3. Okay, so essentially think about a number line with x. Here's -2. Here's -1. Notice in order to get the same y value, we've actually shifted our x values over by 1. Let me make sure I did that the right way. Yes. Okay. So in this case, C would be -1. So our parent graph would move to the right by 1 unit. We could repeat the process with the rest of this. These would turn into 0, 1, and 2. So you can see the X version is kind of weirder. Essentially, we'll cover this like without doing this whole process next. Let me save this picture. I'm gonna go ahead and jump back. So if you need to save the picture, go ahead and take a picture now. Let me stop my share. And then I'm going to open up notes again. Okay, so what I want you to notice, this is our parent on the top. Y equals x squared. And then the translation, we're going to have y equals x minus 5, the quantity squared. Match, remember we had y equals x plus c squared, and if c is positive, we move left by c units. If c is negative, we move right by c units. So hopefully you're seeing from this, c is equal to -5. So we should move right by 5 units to get our translation. Okay, so what that means, you have this point 0, 0, right? You're going to take that point and move it over by 5 units. Okay, so your parent had the point 0, 0. And now your translation has the point 0, 5. Okay, let's choose some other prime points before we move on here. We can see that -2, 4 is a point. We can see that +2, 4 is a point. We can see that that is, it looks like 3, 9 is a point, and -3, 9 is also a point. Now I'm going to rearrange these a bit because I like to have the lowest x value up to the highest x value, which would be kind of the way you graph. So give me a second here to move everything. Okay, I'm just going to rewrite these suckers. It's not even worth moving. All right, so let's draw. Okay, so my parent, -3, 9. -2, 4, 0, 0, 2, 4, 3, 9. And all those points will move right by 5. So you're going to keep the same x values. You're not. Why am I saying that? I think I just caught an error on my part, going through this a little bit too quick. Okay, so if I'm moving right by 5, that means I'm changing my x value, not my y value. Okay, so I caught an error on my part. 0, 0 actually moves to the point 5, 0. I had my x and y switched. Okay, for -3, 9, I'm going to add 5 to my x value. That takes me to 2, 9. See if that works here. 1, 2, 3, 4, 5 is where I'd move. Great. I have -2, 4, so add 5 to my x value. I'm going to get 3 and keep the same y value. Let's take this point, 1, 2, 3, 4, 5. That is indeed, why am I doing, I'm hating this already. That should be a 4. Okay, and then let me be very careful here. So we have 2, 4. Let's watch it on the graph first. Here's the point. Move it over by 1, 2, 3, 4, 5 units. What's the x value there? 7. And the y value is 4. And then 3, 9, move it over by 1, 2, 3, 4, 5. What's the x value there? 8. What's the y value? Same, 9. Okay. So your translated parabola should be right here. And get a little better at those. So let's add this. If you have y equals x plus 5 squared, okay, so your c value is 5, which is greater than 0. We're going to move to the left by 5 units. So remember we had this point, -3, 9, move over by 1, 2, 3, 4, 5. Next point, 1, 2, 3, 4, 5. Next point, 1, 2, 3, 4, 5. Next point, 1, 2, 3, 4, 5. Last point, 1, 2, 3, 4, and 5. Couldn't get that lucky, I guess. There we go. Okay. Let me save that. Okay. And then I have a little bit of time, so I'm gonna go ahead and clear all this out. If you need a picture, go ahead and save it now. Okay. Let's add a couple extra examples here. Actually, just one. If you have y equals x squared minus 2, okay? Then that means you move down by 2 units per our last discussion. See the whiteboard from earlier? So you see this point, move down by 2. This point here, move down by 2. This point here, move down by 2. That is so ugly. So ugly. All right, one more. Y equals x squared plus 2. You move up 2 units. 1, 2. 1, 2. And this one will be off the chart. Over here, up by 2. And this point would also be, this point would be off the chart, okay? So you'd have a parabola that looks like this, roughly, so roughly. All right, so definitely review that portion. This is a question that I would definitely suggest you review in Alex, and if you have some questions, ask me, okay? All right, let me clear this out. So if you need this, go ahead and take a picture. Let me go ahead and take my first pause here in case there are any questions, because I haven't checked in for a minute. All right, so we're moving on to number 13. Use the graph of the parabola below to fill in the table here. So this is a good question to test your knowledge of what you see with your particular function, your quadratic function. So for one, does the parabola open upward or downward? What that means for upward is that you have a smiley face. Downward, you have a frowny face. So we definitely have upward in this case. And just to add some, if you had your quadratic functions either f of x equals ax squared plus bx plus c, or f of x equals a times x minus h, the quantity squared plus k. This would be corresponding with a being greater than 0. Okay. All right, now find the coordinates of the vertex. Remember, the vertex is your min or max point on the graph. And we can see that we have a min here. Start at the origin and move to that point. Out by x, 4, down by y, 1. So vertex is located at 4, negative 1. For the axis of symmetry, I'm going to be giving you parabolas that look like this. They're not going to be sideways parabolas. So for the axis of symmetry, it's going to be the equation. Make note, very important. X equals h. Okay. Now, an easy way to think about that when you see the graph, though, you see where the vertex is? Draw a line through that keeps your parabola symmetric. And then find the equation of that line. X equals, that gives you a vertical line. And then what's the x value there? 4. Okay. And then part D is find the intercepts. So you have your x and y intercepts that you're looking for. Essentially, let's change up the colors a little bit here. We'll do the x-intercepts in orange, y-intercept in green. So remember, the y-intercept is where you your function crosses the y-axis, which happens right here. Okay. Note that that point is 0, 3. And then your x-intercepts are where your function crosses the x-axis. So that happens right here, which is the point 2, 0. Okay, and there's another one for the x-intercept right here, 6, 0. So remember, for the intercepts, you could either put the point or you can just put the value. If it's the x-intercept, you're looking for the x value to be listed. So here you'd put 2 and 6 in commas. And then, so I don't have to scroll down and mess up everything for this. If you have the y-intercepts, note if it's a function, you can only have one y-intercept. Okay. So the y-intercept would be the y value, 3. That covers question 13. I am going to go into question 14 now, which is a little bit more involved. Let me, if you need a picture, go ahead and take one. I'm going to clear this out. All right, let's clear it. And then number 14 is on the next page. Let's see. Yay! Smoothly worked this time. Thank goodness. Okay, so number 14 is here. We are trying to graph this particular parabola. There are a few different ways you can handle this problem, so I will cover it in a little bit more detail. Essentially, method one, you have standard form given here. So you want to start by finding your vertex, which is located at HK. You don't have HK in your standard form equation though. So you need to know that H is equal to negative B over 2A. And K is equal to your function value at H. Okay, so what you're going to do, you're going to plug negative B over 2A into your formula here and find what the Y value should be. Remember, for standard form, you have Y equals AX squared plus BX plus C. Okay. Method two is to complete the square, which will get you to vertex form. Remember, vertex form would be Y equals A times X minus H, the quantity squared, plus K. Then your vertex is located at HK. All right, now the next thing I need to mention for both of these methods is after you do that, you want to make a table. Symmetric about the vertex. And we talked about this in the last few videos. We will see this again in this video. So, so we'll do the same thing here, make a table. Okay, so go ahead and take a picture of that if you need it. I'm going to switch over to the whiteboard shortly. We are going to look at this problem two ways. All right, let me clear this out and then stop share, start share, whiteboard. Come on, don't do this to me right now. Okay, thank you. Clear all drawings. Okay. So we are going to do, this is number 14. Method one to start. We're just going to want to set up our tables, and then we're going to find out that the values are the same. So then you just pick the method of your choice. Okay, so we have y equals 2x squared plus 16x plus 31. Just double check me on that. Make sure it's all good. All right, so now the first thing we're going to do, find the vertex. V at HK, where H is equal to negative B over 2A, and K is equal to the function value at negative B over 2A. So H, remember you, actually, let me go back a little bit. Let's find A, B, and C first. A is 2, B 16, C 31. So now find H, which is negative B over 2 times A. That's negative 16 over 4, which is negative 4. So K is the function value at -4. Remember, F here, okay, when you evaluate, that's the same thing as Y. So you're just plugging in -4 for X here and finding out what is Y there, okay? So F at -4, that's going to be 2 times -4 squared plus 16 times -4 plus 31. Let's go through this one just to make sure it's all good. So this would be 2 times 16 minus 16 times -4. That's -64 plus 31. 32 minus 64 plus 31. -1. So the vertex is located at -4, -1. Okay. Take a picture of that if you need it. I'm going to save it. And then I'm going to clear the whole bottom part out. So once you find your vertex, step 2, make a table with the vertex in the middle. So you have X and Y. Remember, Y is equal to f of X. And that's equal to 2x squared plus 16x plus 31. So the vertex is right in the middle at -4, -1. So we're going to want 2 points on the left side of the vertex and 2 points on the right side of the vertex. Good rule of thumb, take the x value for the vertex, subtract 1, subtract 2. Take the x value for the vertex, add 1, add 2. Now I'll just show you one of these when x is equal to -6. Remember, this is how we're doing it. We're saying, okay, well, y is equal to 2 times -6 squared plus 16 times -6 plus 31. So 2 times -6 squared plus 16 times -6 plus 31. That gives you 7. So when x is equal to -6, y is equal to 7. Calculator for the rest, make it faster. When x is equal to -5, y is equal to 1. And then a good check. If you've done this right, you should have symmetry. So when I test x equals -3, I should get the same y value that I get for x equals -5, which I do. And when I test x equals -2, I should get the same y value that I get when x is equal to -6. Okay, so then what we would do for step 3, plot your 5 points. In this case, it's -6, 7, -5, 1, -4, -1, -3, 1, and -2, 7. Take a picture if you need it. I am going to erase this and go over the second method. Okay. I don't remember what color I used for method 2, so I'll just guess. Essentially, steps 2 and 3 are going to be the same no matter which method you choose. So that part's pretty solid, but let's still go over it. Just want to leave this up top as a reminder of what our point should be. Okay, that didn't work. Let's put it right up there. Okay, so that's what we got from method 1. So let's do method 2 in green. Why not? Whatever. So this is vertex form. You started with y equals 2x squared plus 16x plus 31. We're going to complete the square. This would be a good refresher, especially because the process is slightly different than the completing the square that we did in the last, I think it was the first video actually. So your first step is to factor out the coefficient in front of x squared. And you're going to factor it out of both the x terms, essentially. Okay, so what I mean by this, you see how essentially you're factoring out a. A is 2 here, right? So we're going to factor 2 out of just the x terms. So 2x squared, factor 2 out, you're left with x squared. 16x, factor 2 out, you're left with 8x. Keep the plus 31 at the end. Okay, now your next step. Leave yourself some space. Let's do this in pink. You're going to add a value here to complete the square. Stop your plus 31. Now, so that you do not change your equation, you are also going to subtract the same value out on the same side of the equation. Okay. So in case you've forgotten completing the square, you see that inside the parentheses here, b is equal to 8. Why not put a in here too? A is equal to 1. And c, we don't know it yet. Completing the square, we're going to take b and divide it by 2a. And then we're going to square that and put it here. So 8 over 2 times 1 squared. That's going to be 8 over 2 squared, which is 4 squared. That's 16. Okay. Now, this is where it gets a little bit strange and why you might just want to use the standard form equations if you're comfortable with that. What are we really adding to this side of the equation by putting a 16 right here? There's a 2 out front. That 2 is technically distributed to every single term inside the parentheses. So you're really adding 2 times 16. Okay, so now my formula is y equals 2 times x squared plus 8x plus 16 plus 31 minus 32. Okay, so this part, the second step was the completing the square. The third step, combine like terms and factor the perfect square trinomial that's located right here. So you have y equals 2 times the quantity. This becomes x plus 4 squared. A little hint to you where that 4 is coming from. And then minus 1. This is vertex form. Okay, so what we find is that the vertex is located at the same place. H here is negative 4, and K is negative 1. Okay, let me save this picture. If you need the picture, go ahead and take one right now. Okay, let me add one thing to this actually. This is the long step 1. Okay, to do all this. Okay, let me clear this out. Step 2 and step 3 are exactly the same as it was in method 1. Okay, so basically we're going to make a table and we're going to center that table around the vertex. Let me select this stuff and move it up. Okay, so we saw that this on the top is standard form, and we got the same vertex. Okay, now step 2, table centered about vertex. So x, y, which equals f of x. You have, in this case, your vertex form. So vertex in the middle. We have negative 4, negative 1. So same thing. Take your x value, subtract 1, subtract 2. Take your x value, add 1, add 2. Now, just to confirm, no matter which equation you use, the standard or the vertex form, you're going to get exactly the same value. Let's confirm that. When x is equal to negative 6, y is equal to 2 times negative 6 plus 4, the quantity squared, minus 1, which is 2 times negative 2 squared minus 1, which is 2 times 4 minus 1, which is 8 minus 1, which is 7. Confirm, negative 6, 7 was a point that we should have had on the graph. So if we repeat this process, we will get the same points here. I can't see any of this. There we go. Okay. And step 3 is to plot those points. And they're actually the same as these up here. Save a picture if you need it. We're going to go ahead and plot for number 14. right, let me stop share and share with you the notes again. Okay, so we were here and we found the points that I've already forgotten. The points were -4, -1, -5, -6, 7, 1, 3, 1, and -2, 7. So plot vertex, -4, -1. Plot your other points, -5, 1, and -6, 7. Let's see, -6, 1, 2, 3, 4, 5, 6, 7. There we go. All right, -3, 1, and -2, 7. So our parabola should look like this no matter which method you use. That is so ugly. Make sure to curve on the bottom there. This is like the ugliest parabola ever. Sorry. Again, you should not have that much problem with it because it's Alex. Okay, ugly parabola. Hard to curve on graphics tablet. Okay, so let me go ahead and save that. I'm going to go ahead and pause for a minute to check the chat because I can see some stuff is popping up. All right, you guys, so we did number 14. We're going to end with number 15 for the night. Find the x-intercepts and the coordinates of the vertex for the parabola given here. If there's more than one x-intercept, separate them with commas. Okay, so let's color code this a little. We'll find the x-intercepts in orange. And we'll find the coordinate of the vertex in pink. Why not? Okay, so I'm going to do this on the whiteboard so that I have more room. Take a picture of that. Stop share. And then go to the whiteboard. Come on. Shannon. All right, let me clear all this out. And then this is homework alternate, chapter 7, number 15. Oh no. Okay, there we go. All right, so we're given y equals x squared plus 2x minus 15. We want to find the x-intercepts. Okay, kind of a hint for you. You can, so possibilities. For x-intercepts, you can have 0 of them, 1 or 2 x-intercepts. Okay, you cannot have more than 2, and you cannot have less than 0. Right? For the y-intercept, you can only have 1 for it to be a function. Okay, and then we also wanted to find the vertex. Okay, so let's start with orange. Actually, let's start with the vertex because we've already been doing this, so it'll kind of like give us a little bit of helpful hint into the process. You have a standard form here, right? So what I would suggest, just use the vertex at HK, but don't complete the square unless that's most comfortable for you. Instead, H is located at negative b over 2a, and k is located at your function value at negative b over 2a. So we're going to start by finding H. A is equal to 1, B is equal to 2, C is equal to negative 15. So H is negative 2 divided by 2 times 1, which is negative 2 over 2, which is negative 1. Okay, now what we're going to do to find K, we're going to plug H in to the function given here. Okay, so K is equal to negative 1, the quantity squared, plus 2 times negative 1 minus 15. Okay, that should be equal to 1 minus 2 minus 15, which is negative 1 minus 15, negative 16. So our vertex is located at negative 1, negative 16. Definitely much easier than completing the square for this problem. Okay. Take a picture if you need it. I'm going to clear the bottom part out so that we can find the x-intercepts now. Okay, so for the x-intercepts, kind of think about the graph. If you have x-intercepts, that tells you where you intersect the x-axis. And remember, anywhere on the x-axis, that means that y is equal to 0. Okay, hint, hint, y is equal to 0. So we're going to set y equal to 0 and solve for x. So y is equal to 0. You still have x squared plus 2x minus 15. You have choices here. You could use AC method to make sure it's factorable, or trial and error. You can use quadratic formula if you don't want to deal with all that. This actually is factorable. So you'll factor this down into x plus 5, x minus 3. Okay, a good check, FOIL it out, x squared minus 3x plus 5x minus 15. That turns into x squared plus 2x minus 15, so it checks out. Now from here, we're going to use zero product property. That tells us that x plus 5 can equal 0, or x minus 3 can equal 0. So x turns out to be negative 5 or 3. Alex asks you to separate your answers with commas. So when you put in your x-intercepts, you'll put negative 5 and 3. Note, this is not a coordinate. I'm not putting parentheses around this. It's just giving the individual x values for the intercepts. Okay, so I'm going to save a picture of that. That concludes the stuff that I want to lecture on tonight. Tomorrow I will conclude the chapter 7 homework alternate assignment by going over number 16 through 20. That will be with the PCC group. And then just keep me posted on anything that you might need in the meantime. You can reach me via email or set up a Zoom individually with me if you need to meet. So I'm going to go ahead and stop the recording for the night. and then I will check in.